This lesson is on direct variation and is for November 26th, which is next Tuesday, right before our Thanksgiving break. It says when two variables are related in such a way that the ratio, which is just a fraction, of their values is constant, the two variables are said to be a direct variation. A direct variation is a function in the form of y equals k x, where k is some number that's not equal to 0. So that means it can be a fraction, it can be a whole number, it can be a negative, it can be a positive. It just can't be the number 0. Some ways you'll see it written: y varies directly with x. Do you see any similarities between y equals kx and y equals mx plus b? K and m are the number in front of x, but in this one it has nothing on the end of it, so that means that for a direct variation the b value is 0. So that means this crosses at the origin. Okay. Some other things to think about: as the x value increases, the y value also increases. As one goes up, the other goes up. And likewise, as x decreases, the y value decreases as well. Okay. The constant of variation is what k stands for. Y equals kx, called the constant of variation. K is found by dividing the y value by an x value. Okay. This turns out to be the same as the slope. Okay. Alright, so to find the constant of variation, it helps if you can get something that's in the form of y equals kx. Okay, so in our first one here, y equals kx, and you see that this is in that form, and that right there is your k. So the constant of variation for this one is 2. This second problem here, you would need to solve this for y using the strategies that we've learned in class throughout this year. Box your y, subtract 3x from both sides. That cancels out. You bring down negative 5y. This we're going to rewrite. Still trying to get it kind of in an mx plus b, so that would be negative 3x plus 0. And we divide everything by negative 5, by negative 5, and by negative 5. That cancels. Y equals negative 3 divided by negative 5 goes to positive. 0 divided by 5, that stays 0, so that won't be on the m. So what we see is that this is in the form of y equals kx, and 3 over 5 is our k. Okay. On the third one here, instead of giving you an equation, they give you a table, but we know with our equations, with our tables, we can take and put them in to our calculator, and we can do stat edit, and from stat edit we get pops out y equals 2x. And so if we look at that, y equals kx, then we see that our constant of variation again in this one is 2, which again is just our slope, which is right there in our table. So this has a constant variation of 2. The last one is sort of a little word problem here. And to do it, we have to think back to that first slide where it says that k is equal to the y value over the x value. And it says if a varies directly with b, and a is equal to 6, then b is equal to 36, then we would set this up as 6. Oops, hold on just a second. This would be our x, and this would be our y. And so we would set this up as 36 over 6, and that would reduce to 6. And so our constant of variation would be 6, and our equation for this would be y equals 6x. Alright, now we're going to take a look at what it looks like on the graph here. We have 3 equations here that we're going to look at. And I'm going to set up a coordinate plane here on mine and try blue and see if that'll... So if this is my graph, and this graph ended up being a little bit too small, but if I were going to graph y equals 3x, I know this has an m of 3 over 1 and a b of 0. So my first dot is here at the origin. My second one is up 1, 2, 3 over 1. And so this is what 3x looks like. And so that is a direct variation. If I were going to do 2x, my m is negative 2 over 1 on that one. And again, my b is 0. So it's still going to start here at the origin, but this time it's going to go down 2 over 1. So this is what the negative 2x one will look like. The last one here, equation 3, we could just rewrite it as y equals 1/3 x. This has an m of 1/3, and just like the other two, it has a b of 0. So it's still going to go through the origin here, but it's going to go up 1 over 1, 2, 3. And so it's going to look like that. So this is your 1/3 x. So the common characteristics down here that we notice about these graphs is, number 1, they're all in the form y equals kx, okay? And which was we said was the same as mx plus b. It's just that it does not have the b. The second thing about it is that these always pass through the origin. Okay, so you can see that every one of them passes through the origin, and that's because they have a b of 0. Right. This next set of problems is asking you, are these a direct variation or not? So we're trying to find out, do they fit in the form y equals kx, and do they go through the origin if they're a graph? So this first one up here, so if we look at this, y equals kx, does this fit into the form of that? And it does not, because of this part on the end. So this is no, you're not allowed to have that on the end of it. The second one here, you'd have to go through our solving process, where we solve for y, so we minus 5x to both sides. That becomes 2y equals negative 5x plus 0. Divide everything by 2. And so we get y equals negative 5 over 2x. And 0 divided by 2 is just 0, so this becomes just negative 5 over 2x. So we see that this one does fit into the form of y equals kx. So this is a yes, and our constant of variation is right here, negative 5 over 2. The next one here, we'll solve this one for y. Subtract 4x from both sides. Negative 5y equals negative 4x plus 12. Divide everything by negative 5. And so I get y equals negative 4 divided by 5 stays as 4/5, but it does go positive. 12 divided by negative 5 goes to negative 12/5. And then we see that this is not in the form y equals kx, because it has this part on the end of it, and you're not supposed to have anything on the end of it, so that is a no. Okay. For number 8, you would do stat edit, so I'm going to grab my calculator real quick right here, and I'm going to put this side in L1 and this side in L2. 4, 8, 12 on the left-hand side, 6, 12, 18 on the right-hand side, stat, calc, 4. This comes out to be y equals 1.5x. If I do math, enter, the 1.5 would be 3 over 2x. So this is a yes, this does fit in the form of y equals kx, and k would either be 1.5 as a decimal or 3 over 2. Number 9, same thing, I'm going to do stat edit on it. This will be my L1, this will be my L2. So stat 1, 15, 3, 1. 5, 26, 75. Stat Calc 4, enter. Okay. And in this one, I get y equals negative 3.87x plus 59.8. And so this part on the end makes this a no. On all of these graphs, the first main thing we have to do is see, is it a line? Second thing we have to check is, does it go through the origin? So on number 10, this is a line, but it does not go through the origin, so that's a no. On number 11, this is a line, and it does go through the origin, so this is a yes. The constant of variation is the same as our slope, so all we're going to do is pick 2 points. There's a point, and there's a point. That's down 1 over 1. So this is down 1 over 1, which is just negative 1. Number 12, this is not a straight line, so that's an automatic no. Okay. We're going to write equations using that. We have to find the constant of variation, and then we just substitute that in here. So basically, you're just finding the slope and plugging that in. So number 13 says write a direct variation with a constant of variation equal to negative 3. So that means our k is negative 3. So this one is this. Easy. Y equals negative 3x. Number 14, we're going to have to find this k, or the m, using our point. So here's a point, down 1 over 2. So this is down 1 over 2. So y equals negative 1/2 x. Okay. This next one says write an equation of direct variation that includes 4, negative 3. So it looks like they don't give us very much information, but what we do know is that all direct variations go through the origin, and the origin is a second point. So if I do stat edit with these points, this is L1, this is L2, stat 1, for the x's I put 0 and 4, and for the y's I put 0 and negative 3, stat calc 4, enter. This turns out to be y equals negative 0.75x. So I type in negative 0.75x, math 1, enter, and I find out that this is really negative 3/4 x. So either one of these would work depending on whether your teacher wanted decimals or fractions. Okay, the next one here says your distance from lightning varies directly with the time it takes you to hear the thunder. If you hear thunder 10 seconds away, then you're 2 miles, and that kind of got cut off, 2 miles from the lightning. Write an equation for this relationship. So we know it's y equals something x, and we just have to find the k. The k comes from putting y over x. And it says your distance varies, so that means, that was supposed to be an x. Your distance over your time. Okay, so in this problem our distance was 2 miles, our time was 10 seconds. 2 tenths reduces to 1/5, so we get 1/5 x. And the next one, we're supposed to use proportions to solve. Proportions are where you have something over something and something over something like this, and we use cross multiply, or you guys called it butterfly method back in middle school. And we're going to use that to solve these problems. Okay? So they like for us to set them up as y over x. So I'm going to do y over x for each one. So that was, for the first set that go together, 28 over 7 equals, I'm supposed to find x, so I don't know x when y is 52. So I cross multiply. That's 28x this way. The other way is 7 times 52, which is 364. And then last step, when it's decided, I divide it. So divide both sides by 28. And we get that x equals 13 when we divide it. And number 18, we're going to go about the same way. Y over x, y over x. So 9 and 3 go together. And then we don't know y, and we know x is 40.5. So we cross multiply, usually go to the letter first, so that's 9y. 3 times 40.5 is 121.5. When it's beside it, we divide it, so divide both sides by 9. And we get that y is 13.5. Number 19 and 20 are more real-world problems. And you really don't, you can set these up either way. 8 over 290. So I did gallons over miles. And I just need to make sure I do it the same way on the other side. How much gallons? So gallons is what I'm looking for 400 miles. So 290x. 8 times 400 is 3,200. When it's beside it, we divide it, so I divide both sides by 290. And 3,200 divided by 290 is 11.03. Okay? So it would take 11.03 gallons of gas to go that far. Last problem, number 20. Julio's wages vary directly with his hours worked. So I have wages and hours. So 5 hours gets him $29.75. We compare that to 30 hours, and we want to know what he makes. So 5 times x is 5x. 30 times 29.75 is 892.5. When it's beside it, we divide it, so divide both sides by 5. And x is 178.5, so he will make $178.50 for working 30 hours.